This call is now being recorded.
So now we are live. Good morning, all of you. A warm welcome. And my screen is visible to all of you. And today we are going to learn unit number 2 from the GTU syllabus for the probability and statistic. And unit 2 is having a label, some spatial probability distribution. So we're going to learn some spatial probability distribution. Now, for this particular unit, there are some prerequisites. Is it before moving for the spatial probability distribution? There are some prerequisites. What are that? Hopefully, we are clear about some of that terms. And I'm talking about probability. You guys are quite good how to find probability of one of the event. We are quite good with the definition of probability, different kinds of definition of probability. Then conditional probability से भी हम comfortable है हर कोई बंदा. How to find conditional probability of one of the event if one other event is already occurred. Is it तो ये पता है हमको what is P respect to A, what is it A respect to B, is it all that things. Then yes, the most important part, that is random variable. Random variable. What is random variable? Can any of you will reply me in your words? अगर random variable को define करना है तो क्या है? What is random variable? Any of you? It will be good. Disha? It's not like that. Disha is supposed to reply each and every time. Any of you? Let me choose one of them. Keyu Dokia, are you there? Keyu Dokia. Keyu, are you attending the session? Keyu Dokia. You're supposed to unmute yourself, beta. Can you unmute yourself? Yeah, can you unmute yourself?
Yes, sir.
Yes, beta. Can you define random variable in your own words? क्या आप random variable क्या है ये अपने शब्दों में मुझे बता सकते हैं? We are not looking for the exact word to word definition. Okay? आपकी समझ में जो भी है random variable किसको बोलते हैं ये बताइए जल्दी से. Because this is very important. अगर ये पता है सब आपको, you guys are clear with all this, then we are good with the we are good to start the spatial probability distribution. Yes, please, Keyu, it's your turn.
Sir, no idea.
Uh-oh. Have you attended all the previous session of the Chetan sir?
Sir, last lecture not attend. मैं last lecture न तो attend करी.
Last lecture जाओ रिचार्ड स्क्यूनेस ने कुत्तो सी से. Random variable तो सर एनी पेलाना lecture में deliver करेલું છે. નથી આઈડિયા કઈ વાંધો નહીં. કંસાગરા જય કંસાગરા.
Yes, sir.
Yes, beta. Can you?
No, sir. I didn't remember actually.
સુતા lecture attend કરે છે, બેસીને કરે છે?
Yes, sir.
શું yes, સુતા lecture attend કરે છે? અવાજમાં જોશ હોવો જોઈએ. સારું મ્યુટ કરી દે તારી સેલ્ફ. દીર્ઘા Adhari.
Yes, sir.
Yes, beta. Can you explain what is a random variable?
Yeah, possible values,
Yes,
outcomes or numerical outcomes of a random experiment.
Get to some of the extent. What is random variable? Usually we guys are using notation. For the random variable, we guys are using the notation capital X, is it? Or let me choose my pen. What's wrong with this? Just give me 1 minute. my pen first. Yes. Good. Random variable. We guys are habituated to denote a random variable with capital letter, either X or Y. Is it? Usually we had deal with X. So random variable X is what is this? Is actually one of the number which we are associating with outcome of the experiment. Experiment के outcome के साथ अगर हम कोई number associate कर रहे हैं, then that number will be known as a random variable. As simple as that, is it? And then after that random variable was further categorized into two part. वो दो पार्ट में कैटेगराइज किया गया था. कौन से दो पार्ट थे बेटा, बताओ मुझे, आप ही बता दीजिए. चलिए. दीर्घा, yes. Random variable was categorized in two parts, two different category.
Yeah, discrete and random.
Perfect. Discrete random variable and continuous random variable, is it?
Continuous.
Discrete
Yeah,
and
yeah.
continuous.
Continuous.
These are the two different category of the random variable: discrete random variable, continuous random variable. And discrete random variable, that means we were actually dealing with the counting, is it? Counting, counts. And continuous, that means we were dealing with the measurement, measuring. If you are supposed to measure the date, if I'm supposed to measure the temperature of this particular room, then I will need an interval, is it? And if I'm supposed to count a number of female students in the class, number of cars passing from the road, then surely we are dealing with some of the discrete data. That means we are dealing with the counting. अगर counting की बात हो रही है तो discrete है. Measurement की बात हो रही है, if I'm supposed to measure the temperature, if I'm supposed to measure the mass of one of the object, if I'm supposed to measure the height, if I'm supposed to measure the weight of a person, then all that measurements needs a interval. जब हम बात करेंगे continuous की, अगर counting है, then we are dealing with the discrete. So that were these were two major types of random variable, discrete and continuous. और discrete के लिए जो probability function थी, discrete के लिए जो probability function था, उसको हम बोल रहे थे probability mass function. And for the continuous random variable, that probability function was known as probability density function. Types of random variable पता है हमको, we are quite good. What is probability mass function? What is probability density function? ये सब हमको पता है. Probability mass function किसके लिए? Discrete के लिए. ये probability density function किसके लिए होता है? Continuous के लिए होता है. ये सारी बात आपने कर ली है. इसका पूरा डिस्कशन आपने CRV सर के साथ कर लिया है. Then you had already discussed about the cumulative distribution function. ये बात भी आप सीख चुके. Cumulative distribution function is usually denoted by capital F of X. Is it? That probability mass function or probability density function were denoted by small f of X. So notation काफी important है. Small f अगर हम use कर रहे हैं तो that is probability function. If you are using capital F, that means we are dealing with the cumulative distribution function. ये सारी बात आपने दोनों वेरिएबल के लिए स्टडी की हुई है. रैंडम वेरिएबल अगर वो डिस्क्रीट है या तो कंटिन्यूअस है, दोनों के लिए CRV सर ने आपको ये बताया है कि कम्युलेटिव डिस्ट्रीब्यूशन फंक्शन कैसे आइडेंटिफाई करना है. That all these things were covered in the previous sessions. So I'm expecting that you guys are good with this. Then I'm in need of the expected value. What we mean by expected value? Expected value के लिए दो तीन और शब्द है. क्या है? That is, you can use mathematical expectation. You may use the word mean, or you may use the word average. Is it? So आप सभी को पता है कैसे फाइंड करना है mean, median, mode for the probability distribution for the random variable. अगर वो discrete random variable है तो उसका mean कैसे निकलता है, उसका median कैसे निकलता है, mode कैसे निकलता है. If we are dealing with a continuous random variable, then how to find its mean, median, mode. ये सारा concept आपने cover कर लिया. Then after, you are also good with the standard deviation, variance. That means measure of central. That means measure of dispersion. Standard deviation, variance, and then after that, skewness, kurtosis आपने last में सीखा है on the last lab, on the last section. Is it? So these are the topics you guys had covered till this day. अब तक जो भी सारा concept आपने सीखा हुआ उसमें से जो भी important topics है ना, and also topics which I am in need for the second chapter, second unit, that is some spatial probability distribution, वो सारे topic ये है. These are the prerequisites for the second unit. अब ये जो सारे टॉपिक आपने पढ़े हुए, जितने भी टॉपिक पढ़े हुए, इसमें से That was not all first unit. ये सिर्फ first unit नहीं था. This particular thing up to cumulative distribution function, यहाँ तक की बात है ना, probability से लेके cumulative distribution function तक, all these things are included in first unit, unit 1. Then after, expected value, mean, median, that means measure of dispersion, central tendency, and then after measure of dispersion and skewness, kurtosis. All these topics are the part of unit 3. ये unit 3 का part है. तो अब तक जो आपने पढ़ा है ये हमारी स्लाइड के ऊपर है अभी. Among that, some of the topic belongs to unit 1, some of the topics belongs to unit 3. But the important message is that unit 3 is not ended over there. Unit 3 यहाँ पे खत्म नहीं हो रहा. Yet we need to cover some of the topics related to some basic statistics. वो अभी हम cover करेंगे, लेकिन अभी बात करनी है सेकेंड यूनिट की. सो सेकेंड यूनिट के लिए जो प्री-रिक्विजिट है ना, प्री-रिक्विजिट है जो कि मुझे चाहिए थर्ड यूनिट में से, वो सारे टॉपिक्स सीआरवी सर ने आपको करवा दिए हैं. एंड दिस आर द टॉपिक्स. इज इट? So, irrespective to whether it belongs to second unit or third unit, forget about that. Don't worry. Once you are good with the concept, once you are good with the term, then we are not worried whether it belongs to second unit or third unit. Okay? पर देखिए, हमको पता है कि हमारा सिलेबस है वो प्रोबेबिलिटी एंड स्टैटिस्टिक है. प्रोबेबिलिटी एंड स्टैटिस्टिक. तो पूरा जो पार्ट है वो दो हिस्सों में डिवाइडेड है. एक प्रोबेबिलिटी, दूसरा स्टैटिस्टिक. Both these are connected literally, but probability के लिए 2 यूनिट है, फर्स्ट सेकंड, और स्टैटिस्टिक के लिए लास्ट वाले 3 यूनिट है, 3, 4, 5. So we are done with the first one and we are supposed to deal with the second, क्योंकि पहले हमको probability खत्म करनी है. Once we are good with the probability, then and then we are able to deal with the unit 4 and 5, क्योंकि 4, 5 करने के लिए first, second are the prerequisites once again. So अब फर्स्ट खत्म करने के बाद जाना था सेकंड पे, पर सेकंड के लिए कुछ प्री रिक्वेस्ट है जो कि थर्ड यूनिट में था. बोथ दिस इज इट. सो वी आर डन विद दैट. वी आर रेस्ट विद सम ऑफ द टॉपिक्स ऑफ यूनिट 3. वो कब करेंगे? सेकंड यूनिट के खत्म होने के बाद. ठीक है. सो गाइस, होपफुली यू आर गुड विद द लेवल, विद द एक्चुअल पोजीशन कि हम कहां पे हैं और क्या कर रहे हैं. गुड. सो लेट मी इंट्रोड्यूस the third unit, sorry, the second unit, the next unit. The name of this particular unit is some spatial probability distribution. According to GTU syllabus, the weightage of this particular unit is 25%. Look, this is very, very important. The weightage of this particular unit is 25%. That means up to 17 to 18 marks. You guys will have your in your final paper, you guys will have question for 17 to 18 marks from second unit. This is very, very important. In this particular syllabus, 2 यूनिट ऐसे है कि जिसका वेटेज सबसे ज्यादा है. एक है यूनिट नंबर 2 और एक है यूनिट नंबर 5. इन दोनों का वेटेज 25% है. 25%. So unit 2 is very, very important. Unit 5 is also very, very important. So right now, recently we are dealing with the unit 2, जिसका वेटेज है 25%. And what we are supposed to cover in this particular unit, इस यूनिट में कौन कौन से टॉपिक है? As per the GTU syllabus, let me know topics which we are supposed to cover in this particular unit as per the syllabus provided by GTU. First, we will go for the binomial distribution. This will be our first topic. Second, we will move for the Poisson distribution. Then after Poisson approximation to the binomial, that means this is just a part of Poisson. Then normal distribution will be there, exponential distribution, gamma distribution, and related to gamma distribution we are supposed to learn all that stuff which are known as a gamma density. And last but not the least, evaluation of all the statistical parameters for this distribution, for all the above distribution. Statistical parameters का मतलब क्या है? All the statistical parameters means जो कि सीआरवी सर ने आपको करवाए हैं थर्ड यूनिट में से. कौन कौन से? That is mean, median, mode, standard deviation and variance. तो बाइनोमियल के लिए भी मुझे ये सीखना है आपको. How to find mean, median, mode, standard deviation, variance, all that things. Same for the Poisson, same for the normal, same for the exponential and gamma distribution. So this is the topic. These are the list of topic from the second unit which we are supposed to cover. Mainly we are going to cover this phi distribution, binomial, Poisson. Now both this belongs to discrete. ये दोनों होंगे discrete के लिए, discrete random variable के लिए, and normal, exponential and gamma. This three we will learn for the continuous random variable. Is it? So discrete के लिए दो probability distribution सीखेंगे, binomial, Poisson, और continuous के लिए तीन सीखेंगे, that is normal, exponential and gamma. And for all this, ये पांचों distribution के लिए हम mean, median, mode, standard deviation, variance, that means कि all the statistical parameters की बात करेंगे. So this is what we are supposed to do in the second unit. Good. कोई question है यहाँ पे? Then please unmute yourself. Let me know, or you may drop a message over the chat box. Let me know quickly. Are you guys clear about the outline of the chapter or not? Look, 22 students are attending this particular session, and when I'm asking about the response, about the reply, all of you are supposed to at least drop a message over the chat box. जितने भी बच्चे हैं 22, I need all 22 reply on the chat box right now. यस पाल, एक ही को समझ में आ रहा है कि हाँ क्लियर है सर. अभी तक जो मैंने बात की कि दिस इज द आउटलाइन फॉर द सेकेंड यूनिट, कितने लोगों को ये पता है? यशपाल, नूपुर, दिशा, फैनिल, पार्थिव, निश्चित. Okay, good. So now I'm having a reply. Good. So good. Let's try to cover our first distribution, binomial. पहले हम binomial के लिए जाएंगे पर. There must be some of the question in your mind why we are learning this probability distribution. हम ये probability distribution क्यों learn कर रहे हैं? Might be a question in your mind. ऐसा कुछ question होगा आपके दिमाग में. क्योंकि सर हमने already in the first unit we had already learned about the probability distribution. कि probability distribution का मतलब क्या है? We are supposed to give one of the table in which in the first table, in the first row, I'm supposed to write down all the possible values of my random variable 1, 2, 3. Suppose my random variable x is a discrete random variable, and you're gonna take the value from the data set that is 0, 1, 2, and 3. And then we are supposed to write down its respective probability. Suppose it is 1 by 8, 3 by 8, 3 by 8, and 1 by 8. Then this is what? This is nothing but probability distribution related to one of the discrete random variable. तो ये तो हमने सीख लिया. Why we are discussing once again this probability distribution? ये टॉपिक तो हो चुका है, फिर भी हम दोबारा क्यों कर रहे हैं? Might be kind of question in your mind. ऐसे कुछ question होंगे आपके दिमाग में. So first of all, let me clear that questions. Wait. Before going for that particular, let me give you the roadmap. As you know, random variables are divided into two parts. I had already discussed this thing using the previous slide. Random variable जो है वो दो part में divided है, discrete as well as continuous. So हम जो पांच distribution learn करने वाले, that is binomial, Poisson, normal, exponential and gamma. Out of that, binomial and Poisson, both these are the distribution for the discrete random variable, and normal, exponential and gamma distribution, these three are the distribution for the continuous random variable. So the things must be clear in your mind. Once again, we guys are going to deal with the random variables only. Random variable की बात होगी, उसके लिए कुछ spatial probability distribution हम discuss करने वाले हैं, and these are the five. And that five distribution are divided into two parts: discrete distributions and continuous distribution. So let's start with the binomial. But for that, before going for the binomial, let me clear the things. Let me make you guys quite clear about requisite of distribution. Why we need some spatial distribution? क्यों जरूरत, क्या जरूरत है इसकी? Spatial distribution के लिए की जरूरत क्या है? क्यों हम study कर रहे हैं? Why it is included in the syllabus? Is it? Let me take you towards that. Why we need the probability distribution? Now, as I had written on the slide, that most important projects and scientific research study are conducted with sample data rather than deal with the entire population, rather than with data from the entire population. If we are working with one of the project, one of the most important project, or one of the research, then instead of dealing with the entire data, we will be just dealing with the sample. Why? Because to deal with the entire data, to deal with the entire population is never convenient. ये कभी भी convenient नहीं होगा कि आप सारे data के साथ काम करें. Because if we are dealing with one of the research project, research study, then हो ही नहीं सकता कि आप सारे जो data है उन सभी का research करें, नहीं हो सकता. It is time consuming, even it is not convenient economically even. Okay, let me give you one example. Suppose right now the entire world is before that particular COVID vaccine, is it ना? हर कोई देश है वो कोविड ये कोरोना की वैक्सीन के पीछे पड़ा हुआ है. So how the study, how that particular research is going on? कैसे कर रहे हैं वो research? Suppose कि इंडिया में in our country, in India, suppose 3 companies are there. They are supposed to develop a vaccine for the corona. 3 कंपनी जो है वो कोरोना की वैक्सीन डेवलप करने के पीछे पड़ी हुई है. Suppose let's take example of one of the companies. Suppose XYZ company is there, who is trying to identify the vaccine for the corona. तो वो क्या करेगी, कैसे कर रही है? क्या इंडिया में जितने भी कोरोना के मरीज है हर किसी के ऊपर वो ट्राई कर रही है? हर किसी के ऊपर वो ट्रायल लेंगे? नहीं लेंगे ना. It is not convenient, not possible for one of the company, one of the organization, is it? So what they are doing, they are asking for the samples from the government कि भाई आप हमको कोरोना के 40, 50 या तो 100 मरीज दो, हम उसके ऊपर ट्रायल करेंगे. If we got success, then we will go for the phase 2. In the phase 2, if we got the success, then we will go for phase 3. And अगर phase 3 में भी हमारी वैक्सीन कामयाब है, then we will declare that this vaccine, that particular vaccine is good. It's a रामबाण इलाज for the entire population. Is it now? So we cannot deal. Any company cannot deal with the entire population or the entire data. They need to deal with some of the small sample. Is it? Are you getting me? Am I clear? आप सभी को बात समझ में आ रही है जो भी मैं बात कर रहा हूँ? Is it? Good. So it is not convenient to deal with the entire population. We need to deal with the sample each and every time. Now, that sample can create lots of confusion. Let me show you. What is probability distribution? अब ये बात करके मैं probability distribution की बात क्यों कर रहा हूँ? रुक जाओ. It is a way to save the sample data to make prediction and draw conclusion about the entire population. Distribution is a tool which can save the sample data. वो जो sample हमने लिया हुआ है, उस sample को identify करना पड़ेगा कि what is the nature of that particular sample. So to save the sample data, we need the probability distribution. And once, if we are good to shape that particular sample, then we can go for the prediction and we can draw some of the conclusion. तब जाके हम कुछ fruitful conclusion दे सकते हैं कि भाई ठीक है ये वैक्सीन है, वो चलेगी, वो नहीं चलेगी. In that condition this will work, in that condition that will work. Is it? For that we need to identify the nature of our sample. और वो sample का nature identify करने के लिए हमको चाहिए that is probability distributions. कैसे? Wait. It refers to frequency at which most events and experiments will occur. Wait for that. I will explain that line, but further not right now. Probability distribution helps finding all possible values of a random variable can take between minimum and maximum possible values. ये आपको पता है. With the use of probability distribution, you can identify maximum and minimum value that random variable can take. X की सबसे बड़ी वैल्यू कौन सी है, सबसे छोटी वैल्यू कौन सी है, वो हम आइडेंटिफाई कर सकते हैं probability distribution से. ये आपने किया हुआ है CRV सब के साथ. And probability distribution are used to model real life events for which the outcome is uncertain. Now this is very important. Most of the realistic situation ऐसी होती है जिसका outcome है वो uncertain. Then to model such real life problem, we need the probability distribution. Then probability distribution will be used to model such kind of real life events. So this is also important. And once we find the appropriate distribution, अगर हमको पता चले हमारे पास जो sample है छोटा सा, if we are good to identify the appropriate distribution for that particular sample, then we can use it to make inference and prediction. Inference माने कि it's similar to prediction. we can draw some of the conclusion with the evidence, is it? So for drawing some of the conclusion, to give some of the prediction, we need to be sure about our distribution, about our sample. your sample में जो nature है वो कौन सा है, और for that we need the probability distribution. Okay. What we are actually trying to do with the use of probability distribution, look, I can explain this particular figure. Look, the outer circle, the bigger circle represents the entire data, or the word population I can use. This is the population, the outer circle is, and observe. One of the subset I had taken from that population, that is, and I had labeled that particular subset with the sample. So this is the population, this is the sample. I can give one of the example. That outer circle represents the whole set of Marwari student. Marwari के जितने भी बंदे हैं उस circle में. And if I'm gonna choose one of the small sample of EC1 class, 3EC1, then surely 3EC1 is we can say that it is a sample from the Marwari, is it? Huh? So by that way, there's a population, there's a sample, and what I'm trying to do, I'm trying to conclude some of the data for the population. मैं population के ऊपर कुछ prediction करना चाहता हूँ, कुछ conclusion देना चाहता हूँ, but with the use of sample. Sample का use करके we are going to give some of the conclusion for the entire population. That is what our task is. And this entire thing will be covering in our last unit. इसके ऊपर ये जो मैंने figure एक छोटी सी रखी हुई है ना, इसके ऊपर तो पूरा unit है. That is unit number 5, जिसका weightage भी 25% है. Is it? So this is a very, very, very important process. And for this particular process, we need to learn the distribution, which are some special kind of probability distribution. That is what we're going to cover. Now, once again, let me stick with the similar topic. Now, once as I written that, you might be certain if you're going to examine the whole population. अगर मैं हर एक डेटा के साथ हर एक observation को observe करने के बाद कुछ conclude कर रहा हूँ, then I'm damn sure कि my results will be perfect, my prediction will be accurate. But as I said that we are not gonna deal with the entire population. हम कभी भी entire population के साथ बात करेंगे ही नहीं, because it is not convenient, not time consuming. It's quite big, quite time consuming even it is not convenient economically. So instead of dealing with the population, we are actually dealing with the sample. Now, when we are dealing with the sample, but oftentimes we only have the sample to work with, and to draw the conclusion from the sample data, you should compare the values obtained from the sample with the theoretical values obtained from the probability distribution. जो sample में जितनी भी values आपकी आ रही है, आप जो भी उसका mean find करें, median find करें, we need to compare that particular with the theoretical values of that some of the specified probability distribution. Like this, we're gonna identify some of the values, some of the nature from the data, and then we will gonna give some of the conclusion that this data is having a normal function. This data is distributed normally, or it is distributed exponentially, or it is distributed binomially. That is what we are going to do. But I need to talk about the risk also. When we are dealing with the sample, there is always a risk. There will always be a risk of drawing a false conclusion or making false prediction. जब हम sample के साथ बात कर रहे हैं, तो there are always a risk. अगर मैंने sample ही गलत choose किया हुआ है, तो उस sample के माध्यम से मैं जो conclude करने वाला for entire population, surely that will be false. वो गलत होगा. So there is always a risk. वो risk को कम करने के लिए we are having some of the tool. We need to be sufficiently confident before taking any decision by setting the confidence interval. तो वो risk को कम कर सकते हैं using the confidence interval. कॉन्फिडेंस इंटरवल हम कहीं पे भी सेट कर सकते हैं 90%, 95%, 99%, but all these things it will create lots of confusion in your mind what I'm talking about. कि कॉन्फिडेंस लेवल क्या है, ये 90%, 95%, 99% मैंने जो लिखा है ये सब क्या है. So don't worry about that because we guys are going to learn this particular topic which I have written over here right now, right here. ये दोनों बात. All these things we are supposed to cover in the unit number 5. We will deep dive in this topic with our last unit, and the last unit उसका जो नाम है वो है hypothesis testing. So don't worry about this. इसके लिए तो एक पूरा यूनिट पड़ा हुआ है hypothesis testing, but अभी तक ये पता चला कि भाई to conclude some of the things we need the distributions. That is the reason we are learning the probability distribution. Okay, let me move ahead. Probability distribution. Now, many probability distribution can be defined by factors, by its factors, such as its mean and standard deviation. If we are having mean and standard deviation of the distribution, then we will be good to define that particular distribution. Each probability distribution will have a formula. हर किसी की एक formula होगी, unique होगी. जैसे कि बाइनोमियल के साथ बात करें तो उसकी एक फॉर्मूला होगी, पॉइसन की कोई अलग से फॉर्मूला होगी, नॉर्मल की एक फॉर्मूला होगी. Each and every distribution will have its own formula, and all the distribution will have different shapes, models, and classification of probability distribution. There are different shapes, models, and classification of probability distribution, and we need to divide this particular. We are going to divide this probability distribution into two main categories. As we discussed earlier, we are going to discuss about a discrete probability distribution as well as continuous probability distribution. तो हम इन दोनों की बात करेंगे. So first, let's go for the discrete. Let's try to understand how to deal with the discrete probability distribution. So chapter 2 पार्ट में यहाँ से discrete, continuous. पर पहले जो बात थी वो discrete random variable की बात थी, continuous random variable की बात थी. अब हम बात करेंगे discrete probability distribution and continuous probability distribution. Is it? So let's start with the discrete probability distribution. Yes. What is discrete probability distribution? A discrete probability distribution relates to a discrete data. It actually related to the discrete data. It often used to model uncertain events where the possible values for the variable are either attribute or countable. Discrete की बात कब करते हैं? जब हम counting के साथ deal करते हैं, is it? As we discussed. So we are gonna deal with some of the attributes, or we are gonna count some number of experiments, some number of trials. Is it? There are two common discrete probability distribution जो कि काफी फेमस है. दो ऐसे probability distribution है discrete वाले पार्ट में कि जो काफी फेमस है, that is binomial and Poisson. So binomial distribution, this is our next topic. Now we're gonna deal with the binomial. Discrete में बात करेंगे. Discrete में दो useful हैं, दो distribution काफी famous है, that is binomial, Poisson. So let's start with the binomial. And binomial distribution you guys have already learned in your 12th. क्या किसी को याद है? Binomial distribution was the part in your 12th standard syllabus. 12th में जो 7th chapter था, semester 3. I don't know whether you guys were the part of that particular semester system or yearly system. आप जब 12th में थे तो आपके लिए semester system था या फिर yearly था? कोई एक बता दीजिए. आप 11th 12th करके आए या फिर 4 sem करके आए? 1 2 3 4 5 sem, 1 2 3 4 sem. आप semester system में थे या तो yearly system में थे? हेलो नुपुर, दिशा. 12th में जब आप थे तो सेमेस्टर था, सेमेस्टर 1 2 3 4 ऐसा कुछ था, या तो फिर ईयरली सिस्टम था 11th and 12th सेमेस्टर सिस्टम?
ईयरली सिस्टम था 11th and 12th.
ओके, 11th 12th अगर ईयरली था तो 12th में when you were in 12th तो उसमें एक चैप्टर था 7th chapter, that is probability, conditional probability. In that particular unit you had covered this binomial उसका एक पार्ट था. So the first distribution, binomial, is a kind of recall for you guys. You will be quite comfortable with the formula, with the examples. काफी कुछ ऐसा ही होगा जो कि आपने पहले पढ़ा हुआ. Is it? So nothing new. पर अलग क्या होगा, आपने 12th में उसके एट्रीब्यूट्स नहीं पढ़े हैं. You are not good how to find mean for the binomial distribution. You are not good how to find the variance for the binomial distribution. वो सब हम यहाँ पे ऐड करेंगे, ठीक है. So let me take you for the binomial distribution. Now before going for the binomial distribution, then we can apply the binomial distribution. कोई भी डिस्ट्रीब्यूशन है वो ऐसे ही अप्लाई नहीं कर सकते for the data. कोई क्वेश्चन दिया हुआ है और they are asking for some of the probability and you cannot apply any of the distribution. कि आप उसमें बाइनोमियल, आपकी मर्जी हो तो बाइनोमियल अप्लाई कर दे, आपकी मर्जी हो तो पॉइजन अप्लाई कर दे, आपकी मर्जी हो नॉर्मल अप्लाई कर दे, ऐसा नहीं होता. Is it? To apply any of the distribution, to take help from any of the distribution, first we need to be sure that distribution is, that data is suitable for that particular distribution. अगर मुझे कोई डेटा के ऊपर बाइनोमियल डिस्ट्रीब्यूशन अप्लाई करना है तो फर्स्ट आई नीड टू बी श्योर कि क्या यहाँ पे बाइनोमियल डिस्ट्रीब्यूशन सूटेबल है कि नहीं है. Is it? And first our aim must be that how to identify that binomial distribution is suitable. When we can say that we can go for the binomial distribution. Is it? We can go for the binomial distribution if and only if our experiments are binomial experiments. अगर हमारा एक्सपेरिमेंट जो है ना वो बाइनोमियल एक्सपेरिमेंट है, then and then we can go for the binomial distribution. वरना बाइनोमियल डिस्ट्रीब्यूशन अप्लाई नहीं होता है, ठीक है. Now, then in such a case we need to know what is binomial experiment. कि binomial experiment क्या है भाई? A binomial experiment is an experiment that satisfies the following some condition. I'm giving you the list of some of the condition. अगर आपका एक्सपेरिमेंट है वो उस कंडीशंस को फॉलो कर रहा है, सेटिस्फाई कर रहा है, then and then your experiment is binomial experiment. और अगर आपका एक्सपेरिमेंट binomial experiment है, then you can apply the binomial distribution. As simple as that. So let me give you the list. The first one is the experiment is repeated for fixed number of trials. आप जो एक्सपेरिमेंट कर रहे हो वो फिक्स नंबर ऑफ ट्रायल्स के लिए रिपीट हो रहा है, and each trial is independent from other. Let me give you one example over here. Suppose I'm tossing a coin. I'm tossing a coin for 5 times. I'm tossing a coin for 5 times. Then, what I'm doing right now, I'm repeating one of the experiment for fixed number of trials. Is it? I just stated that I'm going to repeat that particular experiment for 5 times. तो फिक्स है कि कितनी बार मैं रिपीट कर रहा हूँ. Fixed number of trial satisfied, and each trial is independent from the other. मैं जब फर्स्ट बार कॉइन टॉस कर रहा हूँ तो जो भी रिजल्ट आ रहा है, either it is head or tail, that result will not affect on the second trial. पहली बार टॉस किया, हेड आया, ठीक है, मैंने फिर से कॉइन उठा लिया, दूसरी बार टॉस किया तो हेड भी आ सकता है, टेल भी आ सकता है. फर्स्ट जो एक्सपेरिमेंट था उसका कोई इफेक्ट सेकंड के ऊपर नहीं रहेगा. We know that. So this is the first condition. The experiment is repeated for fixed number of trial and each trial must be independent from other. The second condition, there are only 2 possible outcomes. This is very, very important. There are only 2 possible outcomes of interest of each trial. हर एक ट्रायल में 2 ही आउटकम हो सकते हैं, 2 से ज्यादा नहीं. That's it. As I had discussed this example, if I'm tossing a coin, then I will surely have 2 possible outcomes, either head or tail. That's all. उसके अलावा और कोई आउटकम हो ही नहीं सकता. We are not in the movie सोले मूवी में नहीं है कि भाई मैं सिक्का उठाऊं, सिक्का टॉस करूं and then that coin will stand, वो खड़ा रह जाएगा ऐसे ही बीच में. नहीं हो सकता ना ऐसा. We know that this is not practical. So each and every experiment must have only 2 possible outcomes, and out of that 2 we can able to associate one of them with success and another with the failure. If I'm saying I'm tossing a coin and getting a head is a success, then getting a tail is failure. Is it? तो 2 ही आउटकम होने चाहिए, उसमें से कोई एक को आप सक्सेस के साथ एसोसिएट कर रहे हैं, दूसरे को फेलियर बोल रहे हैं. Getting? So this is the second condition. Third one, the probability of success is same for each trial. Suppose in this particular example, if I'm labeling my success as getting a head, I'm tossing a coin 5 times. I'm tossing a coin 5 times. I'm repeating the experiment for fixed number of times. Is it? Take care. Each trial is independent. Yes, we know that. there are only two possible outcomes. इसके लिए भी या तो H आ सकता है, या तो H, या तो H, या तो T, या तो H, या तो T, या तो H, या तो T, या तो H, या तो T. Is it? Now I am associating my success as a getting ahead. Getting ahead is a success. Is it? तो पहले में जो सक्सेस की प्रोबेबिलिटी है, that is 1/2. हेड मिलने की संभावना, हेड मिलने की प्रोबेबिलिटी, that is 1/2. दूसरे में भी 1/2, तीसरे में भी 1/2, चौथे में भी 1/2, fifth में भी 1/2. So probability of success is same for each trial. This is very very important. हर बार सक्सेस की प्रोबेबिलिटी सेम रहनी चाहिए, वो डिफर नहीं कर सकती. And the last one, the random variable x counts the number of success full trials. But don't worry about that. This last condition, we're not worried about that. This is actually a kind of information. I cannot say this is condition. Okay, so this is the first three statements are the condition. If any of the trial, any of the experiment is satisfying this three condition, then we can say that that experiment is binomial experiment. And if it is binomial experiment, then we can discuss about the binomial distribution. तो क्या binomial experiment की ये तीन condition में आप सभी clear है? All of you are clear with these three conditions? Yes or no? I need the reply. How many of you are clear about these three conditions for the binomial experiment? Let me know quickly or the chat box. जो भी लोग को पता चल रहा है, एक पार्थिव और एक दीर्घा, बाकी के सारे सो रहे क्या? मिलोनी, दिशा, निशिता, हर्षजीत सिंह, good. Only 5-6 students. Silpi Kumari, Nupur, Keyur, good. What about others? What about the others? Sanjana, then after Niyati, then after Mitul. Reply कीजिए बेटा, Mihir, Meet. Reply all the chat box whether you guys are clear or not. Yes, good. So if you are confident that you guys can identify the binomial experiment, then let me throw one of the example. But before going for the example for the binomial experiment, I need to note down some of the notations which we're gonna use throughout the first distribution. These are some of the standard notation for the binomial. Small n means number of times we're gonna repeat the trial. Small n means number of times we're gonna repeat the trial. So n means number of times we repeat the trial. P means probability of success. Small p, observe here, small p, small and italic. This p means, this is not capital P, take care. Small p means probability of success. If p is probability of success, then q is probability of failure. And we know that the total probability must be 1. So if for each and every time p plus q, small p plus q will be 1. Is it? So if we are having a value of p, then surely we can identify the value of q. P is 1 minus q, or in other words, q is equals to 1 minus p. अगर आपके पास सक्सेस ऑफ probability of success है तो आप फेलियर की प्रोबेबिलिटी आइडेंटिफाई कर सकते हैं. अगर फेलियर की प्रोबेबिलिटी है, then you can identify the probability of success. So small p means probability of success, small q means probability of failure, and x, that small x means number of times we need the success. हमको कितनी बार सक्सेस चाहिए? Is it? So once again, I will say that don't worry about this. The things will be clear about x once we are dealing with the example. Okay. So take care about this 3 and number of times we are repeating this experiment. P, probability of success. Q, probability of failure. So these are the notation. Now I'm giving you one of the example which you are supposed to decide whether the situation I'm going to give you, that situation is related to binomial experiment or not. आपको decide करना है कि क्या ये binomial experiment है क्या नहीं है. So look, this is the instruction. Decide whether the following experiment is binomial experiment. If it is binomial, then specify the value of n, p, and q. What is n? N is number of time we're gonna repeat the trial. P, probability of success. Q, probability of failure. And list all the possible values of random variable x. And if it is not binomial experiment, then explain why. तो नीचे में एक सिचुएशन आपको दूंगा. You need to decide whether that particular experiment is binomial experiment or not. अगर वो binomial है तो 3 values find करेंगे n, p और q. अगर नहीं है तो आप रीजन देंगे मुझे कि क्यों नहीं है. Look, this is the question. This is the situation. You randomly select a card from deck of cards. Suppose you are having a pack of 52 cards in front of you. And what you are supposed to choose, what you are supposed to do, you are supposed to pick a card आपको एक कार्ड सिलेक्ट करना है, एक ही कार्ड, आंख बंद करके। आपके सामने जो पड़ा हुआ है वो 52 पैक का एक 52 कार्ड का पूरा पैक है, and you are going to pick a single card from that particular deck, and then not if the card is a king. If that card is king, then you are supposed to note it down. आपको सिर्फ देखना है कि आपने जो कार्ड सिलेक्ट किया वो किंग है या नहीं, is it? Then you then put the card back. आप वो कार्ड वापस रख देंगे पैक में, and you will repeat the process for 8 times. You're gonna repeat the process for 8 times. क्या करना है फिर से एक बार बता दूं, हिंदी में बता दूं। आपके सामने 52 कार्ड का पूरा पैक पड़ा है, आपको एक कार्ड चूज करना है, नोट करना है। अगर किंग है तो गुड, यू गेट अ सक्सेस। अगर किंग नहीं है तो कोई बात नहीं, आप फेल हो चुके। किंग है या नहीं है, आपको वो कार्ड वापस रख देना है, फिर से उसको सफल करना है। Once again you are supposed to pick a card. You need to decide whether you got success or fail. Then you are supposed to repeat the similar kind of process for 8 times. Now, my question is for you guys. We need to decide whether this particular experiment is binomial experiment or not. If it is binomial experiment, then I will interested to know the value of n as well as p as well as q, where n is number of times we are repeating the trial, repeating this particular experiment, p probability of success and q probability of failure. Is it? So your time start now. I'm giving you just 1 or 2 minutes. Think about this, and then I will pick a random student from the list and will ask for the solution. Your time start now. I'm giving you just 1 minute. 1 minute. Either you may reply over the chat box or you may unmute yourself and talk to me. Look, we need an interactive session, is it? You may reply over the chat box or you may unmute yourself and talk to me. Disha is saying yes, it is binomial experiment. Disha, in such a case, you will explain what will be the value of n, p and q. But wait, Miloni is saying yes, it is. The value of n is 8, probability of getting a king. P की मतलब है किंग मिले उसकी संभावना, perfect, good. P and Q, you are correct about this. Path is saying yes, it is binomial. Okay, path is giving us the value of n, p and q, perfect. That is 1 by 13, 48 by 52, perfect. Path, you are absolutely correct. Parthiv, sorry, not path. Any other? क्या हर किसी को, कितनों को, how many of you are getting these things? Look, we are not worried about some of the content that I'm not here with one of the target that I'm supposed to cover the first 15 or first 20 slide, is it? It is not like that. As I said, this unit is having 25% weightage from your syllabus, as well as this unit is quite rich in terms of knowledge. If you are good to get these things, good to get the things related to probability distribution, then you will able to learn, you will get the things related to 5th unit, is it? So if I'm making you guys bore with such kind of PPT, then please let me know. I will choose some other way to explain, but please try to talk with me. दिशा, क्या ऐसा ही होता है आप में से कोई बच्चा सीआरवी सर के साथ बात नहीं करते कभी बीच में? ऐसे ही चुप वाली लैब रहती है ये दिशा?
नहीं, आप जैसे करो ना वैसे चेतन सर है ना, किसी को भी लेके पूछते हैं, उसको आंसर देना होता है।
Oh, that means I'm supposed to pick a person from the audience, is it?
यस।
चलिए थोड़े से ज्यादती करते हैं हम लोग तो ठीक है। दिया, अनिल, जय, देव, खुशाल, खुशाल, can you? खुशाल,
Yes, sir.
can you decide whether the situation is binomial or not? This particular experiment is binomial experiment or not? Can you identify this? पता चल रहा है आपको कि बस वही क्या पता चला मैंने बाइनोमियल के लिए क्या बोला, कैसे एक्सपेरिमेंट को बाइनोमियल बोल सकते हैं बताओ. Are you attending the session properly? Yes or no?
Yes.
Are you interested? Are you interested? Keyur. Sorry, Kushal. Kushal, mute yourself and once again I will ask you after 3-4 minutes. So please be attentive. Jadeja.
Okay.
Jadeja. Am I audible to you, Jadeja? Yaspal Singh.
Yes, sir. Okay.
Yaspal Singh, are you there?
Yes, sir.
हाँ बापू. બાપુ સમજાય છે તમને આપણે જે વાત કરીએ છીએ પ્રોપર?
હા સર.
સરસ રીતે?
હા સરસ રીતે.
સરસ. તો મને કે આ જે એક્સપેરિમેન્ટ છે, this experiment, શું આપણે આને બાયનોમિયલ એક્સપેરિમેન્ટ કહેશું બાપુ કે નહીં?
કહી શકીએ.
કહી શકીએ. એટલે ન કહેવું હોય તો ન પણ કહી શકીએ?
ના ના કહી શકીએ.
કહી શકીએ. સરસ. ચાલો તો શા માટે કહી શકશું કે કહો
કાર્ડ પાછું મૂકી દેતા હતા ને એટલે.
સોરી, કાર્ડ પાછા મૂકી દેતા હતા એટલે. પરફેક્ટ. There you are. When you are what we are supposed to do, we are replacing that particular card before going for the next trial. हम हर बार जो कार्ड सेकेंड टाइम जो कार्ड लेंगे उससे पहले फर्स्ट वाला कार्ड अंदर रख देंगे ताकि the same event will be repeated for 8 times. So here it is a binomial experiment, exactly correct. This will act as a binomial distribution. Why? Binomial experiment. I cannot use the word distribution. This is binomial experiment. Why? Because each of 8 selection represent an independent trial. हर बार वो independent होगा. Because the card is replaced before the next one is drawn. हर बार दूसरी बार कार्ड पिक करने से पहले पहला वाला जो कार्ड है वो वापस रख रहा हूं. दैट मींस कि हर बार किंग मिलने की प्रोबेबिलिटी जो है ना वो सेम ही रहेगी. आपको पता है इफ यू आर हैविंग 52 कार्ड्स इन फ्रंट ऑफ यू, दैट 52 कार्ड इज डिवाइडेड इनटू 4 शूट्स. 13 13 13 ऐसे 4 शूट होते हैं. आपको पता है उसको गुजराती में क्या बोलते हैं? चोकड़ी, चरकट, लाइक दैट. आई डोंट नो. चरकट, फली, काड़ी अने लाल. Is it ना? हर एक शूट, in each and every shoot we are having a single king. Is it? That means out of that 52 cards we are having 4 kings. So if I'm finding a probability that getting a king from that particular 52 cards, then the probability will be 4 by 52. Maniki, that will be 1 by 13. Is it now? Now that probability will remain same for each and every trial. हर बार है जो हम 8 बार वो पिक कर रहे, हर एक बार probability of getting king will remain same because we are replacing the card. Is it? So we are repeating the trial for 8 times. So the value of n will be 8. Now, first of all, we need to decide the P. Okay, what is P? As we know that P is a probability of success, but we need to associate success with one of the word. हमको success भी तो किसी के साथ associate करना पड़ेगा ना. किसको हम success बोलेंगे अभी? अगर मैं जो कार्ड पिक कर रहा हूँ, that card is of king, then it is success. So P is a success, and that success means getting king, getting a king. So king मिले तो उसको success बोलते हैं. ठीक है? So P, probability of getting king, as we discussed, that will be 1 by 13. Now once we are having a value of P, then Q will be 1 minus 1 by 13. That means 12 by 13. So ये P और Q की वैल्यू हर एक के लिए हर बार जो 8 बार हम रिपीट कर रहे हैं हर बार सेम रहेगी. So yes, this is binomial. The value of n, P and Q will be 8, 1 by 13 and 12 by 13 respectively. Now The one more thing we need to decide, that is a value of random variable x. Now what is x? ये मैंने आपके साथ बाकी रखा था, क्या बोला था कि x is number of times we need the success. X means number of times we can get success. X is number of successes we need. Number of success. अब देखिए यहाँ पे n की वैल्यू 8 है, as we described, p की वैल्यू is 1 by 13, the value of q is 12 by 13. अब if I need to identify the value of x, कोई बोल सकता है मुझे कि अगर मैं यहाँ पे 8 बार ये सेम प्रोसेस रिपीट कर रहा हूं, एक कार्ड ले रहा हूं, एक कार्ड पिक कर रहा हूं, नोट कर रहा हूं किंग है या नहीं, अगर किंग है नहीं है तो फेलियर, इज इट? आई एम रिपीटिंग दिस एक्सपेरिमेंट फॉर 8 टाइम्स. Can you give a comment related to the number of success? If x is my number of successes, number of successes, then x की वैल्यू क्या हो सकती है? अगर मैं 8 बार ट्राई कर रहा हूं तो कितनी बार सक्सेस मिल सकती है? 1 बार, 2 बार, 3 बार, 8 बार, 16 बार, कितनी बार हो सकती है? What should be the value of x? Yes, Parthiv, you're absolutely correct. As Parthiv said that here x can take the values from the range 0, 1, 2, 3 up to 8, maximum 8. क्या पार्थिव 8 के बाद आगे हो सकता है? क्या मुझे 9 बार सक्सेस मिल सकती है? क्या मुझे 10 बार सक्सेस मिल सकती है? Parthiv, it will be fine if you are unmuting yourself and talk to me. Parthiv, it's advisable that you unmute yourself and talk to me, please.
No, sir.
क्यों नहीं हो सकता बेटा, बता? क्योंकि हम ज्यादा से ज्यादा 8 ही बार ट्राई कर रहे हैं ना. हो सकता है a person is quite lucky, तो हर बार उसे किंग मिल रहा है, that means he got 8 success out of 8 trial. हो सकता है किसी एक बंदे को 7 बार सक्सेस मिल रहा है, 7 बार किंग आया, 1 बार किंग नहीं आया. और हो सकता है a person is quite unlucky like me, and out of that 8 trials I'm not able to get a single king. मैंने 8 बार वो कार्ड चूज किया, पर एक भी बार मुझे किंग नहीं है. हो सकता है, इट्स क्वाइट पॉसिबल. सो 0 हो सकता है, 1 king will be there, 2 kings, 3, 4, 5, 6, 7 and maximum it will be 8. is it? So देखिए, कोई यहाँ पे ऐसा ना समझे कि 8 किंग मिल रहा है मुझे. I'm not 8 किंग नहीं हो सकते पैक में. We are not talking about that number of king card available in the pack, is it? So don't get confused on that. What we are looking for number of successes. I'm repeating this event 8 times, and out of that 8 times मुझे कितनी बार सक्सेस मिली? 0 बार भी हो सकता है, 1 बार भी हो सकता है, और हो सकता है 8 बार मुझे सक्सेस मिली. Is it? So this is my value of x. Now you can observe x is my random variable. You can clearly observe here x is discrete data. X is discrete data. 0 के बाद 1 है, 1 के बाद 2 है, 2, 3, 4, 5 up to 8. Is it? So this is nothing but a discrete random variable. So discrete random variable x can take value 0, 1, 2, 3 up to 8. So let me erase all the things and let me show you the value of x. Yes, here x can take the value 0, 1, 2, 3 up to 8 only. Is it? So this is the way you can decide whether the provided experiment is binomial experiment or not. Let me give you one more example. Now I will not gonna help you for the second situation. This instruction is saying you need to decide whether the following experiment is binomial experiment or not. अगर ये binomial है तो आपको n p और q की वैल्यू देनी है. अगर नहीं है तो आपको explain करना है why it is not binomial. The situation is that you roll a die 10 times and note down the number of die lies on. You are supposed to throw a die. आपके हाथ में एक डाई है, आपको थ्रो करना है. आपको उस डाई के ऊपर जो भी रिजल्ट आ रहा है, जो भी नंबर आ रहा है, उसको नोट करना है. Is it? Now you need to decide whether this will act as a binomial experiment or not. Giving you the time of 1 minute. Don't give your answer over the chat box. तो सभी को पता चलेगा. I will pick a random person. Just decide क्या ये रैंडम, ये बाइनोमियल एक्सपेरिमेंट होगा कि नहीं होगा. मैं किसी को भी पूछूंगा. अभी चैट बॉक्स में मत डालिए आपका आंसर. आई विल गिव यू द टाइम व्हेन यू विल गिव योर आंसर ओवर द चैट बॉक्स. ओके, just be clear. I'm giving you just 1 minute because I need to take one call. So I'm muting myself. I will be back within just a single minute. Okay, I'm just here. Yes, please. Who will help me to determine whether this situation leads to the Bernoulli, or we can say binomial experiment, or not? Who will help me? Who will help me? वॉलेंटरी तो कोई आएगा ही नहीं आप में से. Okay. Niyati Doshi, are you there? Niyati Doshi, are you there? Niyati Doshi. Nishtha Karya. Niyati Doshi, Nishtha Karya. Yes, Nishtha. Can you decide whether this particular experiment is binomial experiment or not?
No, it's not.
Why?
Because in previous example, getting king was considered a success. But in this,
I had not said which is your success. Is it not?
yes.
If you're just supposed to note down the number the die lands on, that means in that case you will have 6 different options. Your die can land on 1, 2, 3, 4, 5, or 6. Is it now?
Yes.
I had not provided which of them is success. So yes, here it is. This particular experiment we are repeating for 10 times. ये correct है. हर बार जो मैं roll करूंगा die, उसमें जो भी result आ रहा है वो दूसरे से independent है, तो first condition satisfy हो रही है. But the thing is not clear with whom we are supposed to associate a success. Is it ना? अगर मैं यहाँ पे एक बात और add कर दूं कि getting a number 1 is success, then surely this will act as a binomial. But
Yes.
here the thing is not clear. Is it not? Let me show the solution. Yes, no. This is not binomial experiment. While each trial is independent, यहाँ पे हर एक try तो independent ही है, as we discussed. But there are more than 2 possible outcomes. 1, 2, 3, 4, 5, 6. अगर इसको आप ही बताइए निष्ठा, अगर इसको हमको if we want to transform this particular into binomial, तो क्या करना चाहिए? अभी ये binomial experiment नहीं है, पर अगर इसको binomial बना देना है, तो क्या करेंगे? एक छोटा सा चेंज और ये binomial हो जाएगा.
Like we will add that getting 1 is success or
Yes.
getting 2 is success.
Yes, getting 1 is success. Then success की probability होगी 1 by 6, is it? In that case, failure, the probability will be 5 by 6. If you are saying that getting 1 is a success, is it? Nah.
Yes.
But here, it is not provided. So ये binomial नहीं है, पर इसको binomial बना सकते हैं. दूसरी तरीके से भी बना सकते हैं. चलो, अगर मैं ऐसा करूं कि getting an even number is a success. Getting an even number is a success. तो even number कितने? 2, 4, 6. 2 आए तो भी success, 4 आए तो भी success, 6 आए तो भी success. And in that case, 1, 3, and 5 will be considered as a failure. So in that case, probability of getting success will be 3 by 6. That means 1 by 2, and Q will be also 1 by 2. And the value of N will be 10. हो सकता है, ऐसा बिल्कुल हो सकता है. Is it? So this is not for with this particular situation, with this particular content of data. This is not binomial, but we can convert that particular into binomial. पर अभी तो ये binomial नहीं है. ठीक है? So good. Now, so finally we are loaded for the binomial distribution. उसके लिए कुछ जो prerequisites है जो हमने बात कर ली है, देख ली एक बार. The probability distribution that used for the data which can only take one of 2 value, 2 ही value हो सकती है, then and then it is binomial. या तो for example whether we are dealing with pass or fail or yes or no, good or defective, है या नहीं है, like that. Is it? Then and then it is binomial. It allows to compute the probability of number of successes for the given number of trial. जो हम binomial अभी study करेंगे, binomial distribution जो अभी study करेंगे, that allows us to compute the probability of number of successes out of number of given of trials. Is it? Then this is very, very important because that is the reason I had mentioned that particular with the red ink and bold letters. Success could mean anything you want to consider. Success कुछ भी हो सकती है. आप किसी के भी साथ success को associate कर सकते हैं, whether it is positive outcome or negative outcome. In the earlier first example, हमने क्या बोला था? Getting a king is a success, is it? Getting a king card from the deck of 52 card is a success. King मिले तो success है. अब वहीं पे हम ये भी बोल सकते हैं अगर किंग मिले तो वो फेलियर है। इन दैट केस क्या होगा, पी और क्यू की वैल्यू बस ट्रांसफर हो जाएगी, जो पी की वैल्यू थी वो क्यू की हो जाएगी, क्यू की थी वो पी की हो जाएगी। So success could mean anything. You can associate success with the positive outcome or negative outcome. ऐसा कुछ नहीं है कि सक्सेस सिर्फ पॉजिटिव आउटकम के साथ ही जाएगा। ऐसे उस गेम को अगर हम ऐसे भी ऐसे डिजाइन करें कि आपके पास 52 पैक है, 52 कार्ड्स है, अगर आपको एक कार्ड चूज करना है, अगर किंग आया तो आप आउट है, और किंग नहीं आया तो यू आर इन द गेम। इन दैट केस गेटिंग ए किंग इज द नेगेटिव आउटकम, इज इट? तो उसको भी हम सक्सेस बोल सकते हैं। इट्स टोटली फाइन, इट्स टोटली फाइन। So success could mean anything to you. You want to consider as positive or negative. We're not worried about that particular. And finally, now we are ready and loaded to discuss about the binomial probability distribution. Now we are going to discuss about its formula. कि binomial probability distribution की formula कैसी होती, how to find its mean, how to identify its median, and all that things. Let me take you for that particular slide, the binomial distribution formula. In a binomial experiment, look, observe. The binomial distribution formula, the statement has started from the binomial experiment. We can deal with the binomial distribution if and only if we are dealing with the binomial experiment. पहले हमको पता होना चाहिए कि हमारा जो एक्सपेरिमेंट है वो binomial experiment है, तभी वो डिस्ट्रीब्यूशन की बात हो सकती है। In a binomial experiment, the probability of getting exactly x number of successes in n trial में से x सक्सेस अगर हमको चाहिए, माने कि 10 में से 2 सक्सेस चाहिए, 10 में से 8 सक्सेस चाहिए, 10 में से 10 में सक्सेस चाहिए, then in such a way that if we required exactly x successes out of n trial, then the formula is like this: probability of x equals to x, ncx, p raised to x, and q raised to n minus x. Here I had used some of the notation and I had already make you guys clear about the notation. Small n means number of trials, p means probability of success, q means probability of failure, small p and small q means probability of success and failure, n means number of times we are going to repeat that particular trial, and x means number of successes we require. X means number of successes we require. अब यहाँ पे जो दूसरा मैंने simplification दिया हुआ है, this is just a simplification of ncx. ये इसका छोटा सा एक सिंप्लीफिकेशन है. दिस इज वन ऑफ द फॉर्मूला, सो डोंट वरी अबाउट दिस पार्ट. ये इसके लिए कोई चिंता करने की जरूरत नहीं है. दिस इज जस्ट द फॉर्मूला फॉर द बायनोमियल डिस्ट्रीब्यूशन. दिस इज व्हाट वी आर सपोज्ड टू रिमेंबर. दिस इज व्हाट वी आर सपोज्ड टू डील विद थ्रू आउट दिस पर्टिकुलर टॉपिक बायनोमियल. ये वो फॉर्मूला. अब थोड़ा सा याद कीजिए, क्या ये फॉर्मूला कहीं आपने देखी हुई है? यू गाइस हैड ऑलरेडी इंटरेक्टेड विद दिस पर्टिकुलर इन योर 12th. ये फॉर्मूला आपने देखी हुई है. इस फॉर्मूला के साथ आपने काम भी किया हुआ. कहां पे? आपके 12th में. याद है किसी को? एनी ऑफ यू आर एबल टू रिकॉल दिस फॉर्मूला? क्या कोई बंदा ऐसा है लैब में से जिसको ये फॉर्मूला याद है? आउट ऑफ दिस 21 स्टूडेंट आई एम हैविंग इन फ्रंट ऑफ मी, किसी को भी ये याद है कि नहीं? 12th में ऐसा कुछ आया था? ड्रॉप अ मैसेज ओवर द चैट बॉक्स राइट नाउ. कितने लोग हैं जिसको ये याद है कि हाँ पे ऐसा कुछ फॉर्मूला था 12th में? ड्रॉप अ मैसेज ओवर द चैट बॉक्स क्विकली right now. Not exactly. Okay, Nupur ko nahi yaad hai. It is in 11th. Okay, 11th, 12th. I'm not worried about 12th or 11th. It's okay. Yes, sir. There was something like that. Yes, but हाँ था. Yes, we came across it. Yes, I think it's in 12th. Yes, as per my information, as per my knowledge, that was included in the syllabus of 12th standard. पर ऐसा कुछ था. And this is what our first topic is. Binomial जो हम करेंगे वही है, यही है. So kind of recall we can say. And let me share two more things with you. Binomial distribution is fully defined if we are having two parameters. N और P की वैल्यू अगर हमारे पास है ना, we can determine all this. So that is the reason N and P are called the parameters of Bernoulli और तो बायनोमियल डिस्ट्रीब्यूशन. बायनोमियल डिस्ट्रीब्यूशन के पैरामीटर्स के बारे में कोई आपसे पूछे, दैट मींस n and p are the parameters. Both these are the parameters. Why n and p? Why I'm not including q? Because we are having a fixed relation between p and q. अगर p है आपके पास तो आपको मिल जाएगा q. 1 minus q is p or q is 1 minus p. Is it? So we just need two parameters, that is n and p. Both these are known as the parameters of binomial distribution. As well as we need to note down one more thing. Here n n means number of times we're going to repeat the trial. कोई एक एक्सपेरिमेंट हम कितनी बार रिपीट कर रहे हैं, तो वो पॉजिटिव इंटीजर ही हो सकता है. Surely it will be a positive integer. या तो हम एक बार रिपीट करें, या तो 2 बार, या तो 3 बार, या तो 4 बार, या तो 50 बार, या तो 100 बार. Is it now? We cannot say we are repeating one of the experiment for 2.5 times. कोई एक गेम है वो 3.5 बार नहीं खेल सकते ना, या तो 2 बार या तो 3 बार. That means what I want to say, n will be surely a integer, and the value of n will be surely integer, and the value of p, the second parameter is p. Now what is p? P is actually the probability of success. तो हमको पता है probability of success, probability of any of the event will be lying between 0 and 1. या तो 0 होगी, या तो 1 होगी, या तो उसके बीच में कुछ होगी. That means p can take any value between 0 and 1. So p की वैल्यू 0.00 समथिंग हो सकती है, p की वैल्यू 0.5 हो सकती है, p की वैल्यू 0.4 हो सकती है, p की वैल्यू 2/3 हो सकती है, is it? But the value of n will be surely a positive integer. Here is a kind of typo. I need to use less than or equals to. Yes, 0 is less than equals to, p is less than equals to 1. p की वैल्यू 0 और 1 के बीच में कुछ भी हो सकती है, जबकि n है वो पॉजिटिव इंटीजर ही होगा. Now using this, we guys this is advisable that you guys will remember this formula. ये formula आपको याद होनी चाहिए for the next examples. And let me erase all the ink from the slide. That will be convenient for you. Try to remember this formula. एक बार देख लीजिए, p of x equals to x. This is capital X, this is small x. This is not kind of typo. ये intentionally लिखा हुआ है कि ये capital X है, ये small x है. This is the random variable. This is the value of that particular random variable. So let's discuss for the mean for this particular mean median की एक बार बात कर ले, फिर we will be loaded for its example. What will be the mean of binomial distribution? Is probability. Binomial distribution is a kind of probability distribution, we know that. अब उसका mean कैसे find करते हैं? Now before that, before going to discuss about its mean, I'm damn sure you guys are aware about mean of discrete random variable. You guys are aware how to find mean of discrete random variable. ये पढ़ा हुआ आपने CRV सर के साथ. If x is my discrete random variable, then its mean will be labeled as e of x. अगर x मेरा discrete random variable या तो फिर continuous, we are not worried about that. पर उसका mean जो है वो denote करते e of x है, या तो उसके लिए notation था mu, you were using that. उसके लिए और एक word था जो आप use कर रहे थे, that is mathematical expectation, is it? So mean for the discrete random variable is e of x. Notation for that is e of x. And when we are dealing with the binomial, that means we are dealing with the discrete random variable, क्योंकि ये जो distribution है वो discrete random variable के लिए ही, तो उसका mean भी denote होगा e of x है. अब इसका mean है क्या? इसका mean है n into p. N into p will be the mean of this particular. But how? Why? But let me recall some of the things. What was the definition of e of x? किसी को याद है? E of x की definition क्या थी mean के लिए? It will be good if anyone of you can recall that. ये तो वही बात है कि जो आपने 2 लैब से पहले CRV सर के साथ पढ़ी हुई थी. CRV sir had explained how to find expected value of one of the random variable capital X. क्या थी उसकी फॉर्मूला? मिहिर आप बताओ. मिहिर या तो संजना, दो में से कोई एक बता दे मुझे. Expected value की फॉर्मूला क्या थी for the discrete random variable? What was the formula for the expected value for the discrete random variable? Jaldi se, Mihir, Sanjana, are you there? Are you attending this? Yes, please. Go ahead.
I don't know.
You don't know. अब ऐसे जितने भी बंदे हैं ना, I don't know वाले, we are just gonna hit our first midterm examination. Huh? It will create a problem. So try to be focused with the content. The formula was e of x equals to summation x p of x. That was the formula. Or CRV ने बताया था with one of the parameter I is running from 1 to up to n xi p of xi. That was the formula. And if you are dealing with the continuous random variable, तो instead of तो यहाँ पे जो summation मैंने लिखा है उसकी जगह पे आप सिर्फ कर रहे थे integration x f of x dx. That was the formula for the expected value, or we can say mean, for the discrete random variable. Now, using that particular formula, the expected value e of x for the binomial distribution is nothing but the same. Once again, I'm going to interact with the similar formula, summation x p of x, and for the p of x is what? The probability function. अभी हमने पिछली स्लाइड में बोला कि p of x की वैल्यू क्या होगी? P of x is ncx, p raised to x, and q raised to x. Is it? Yeah, I should use capital P. I should be using capital P. This is a kind of typo once again. So this is ncx, p raised to x, q raised to x, and simplification of this. We are not interested in that particular simplification because none of the faculty will gonna ask you, okay, what is the proof for that expected value is n into p. But if anyone is interested that what I had done over here, just बहुत ही simple सी बात मैंने की है, इससे summation में x की value मैंने run की हुई है. पहले मैंने x लिया हुआ है 0. If I'm gonna take x as a 0, then the first value will be 0 into anything. It will be 0 plus. Then I'm taking x equals to 1. Then 1 into nc1 p raised to 1 q raised to n minus 1. Observe here. Then I had chosen n equals to 2. Then n equals to 3. And lastly, I had chosen n equals to n. Then n minus n will be 0. Q raised to 0 will be 0. Q raised to 0 will be 1. So ये निकल जाएगा यहाँ से. So we are not interested in this particular proof. Forget. Don't worry about this particular कि ये कैसे हुआ है. But observe this. The expected value for the binomial distribution will be n into p. Here it is. Expected value of binomial distribution will be n into p. Let me choose the similar way. If we wish to find the variance, variance की भी एक छोटी सी फॉर्मूला थी, सीआरवी सर ने आपको बताई थी कि variance of x, the formula was अभी आपसे पूछूंगा तो आप यही बोलेंगे कि I don't know, e of x square minus e of x the whole square. That was the formula for the variance, is it ना? ये सब पढ़ा हुआ है. Actually this belongs to the third unit, पर अभी मुझे जरूरत है, इसलिए that was the reason कि why CRV sir had explained, delivered the content before the second unit. वो third unit का छोटा सा एक part पहले क्यों लिया गया? इसका reason यही है, because we need to interact with mean, variance as well as standard deviation. So using this particular formula of variance, if you're gonna simplify this particular for the binomial distribution, binomial experiment, then the variance of x will be n into p into q. Mean क्या था? n into p. Variance will be n into p into q. And we are knowing the relation between standard deviation and variance. अगर हमारे पास variance है तो उसका square root, positive square root जो निकाले उसको हम बोलते हैं standard deviation. So these three are quite important. Expected value binomial के लिए, that is n into p. Variance for the binomial distribution, that is n into p into q. Standard deviation is square root of n into p into q. These three are quite important. Take care about this. ये भी आपको याद होना चाहिए. CRV sir will gonna share the same PPT with all of you after this particular session. Evening तक ये PPT आपके साथ share हो जाएगी. So you can go through it as many times as you want. Let me move ahead. We had discussed about the mode. We had discussed about the mean, standard deviation, and variance. Now we need to deal with the mode also. Okay, how to find mode for the binomial distribution. Now mode for the what is mode? Mode क्या था? Mode is actually the value of x for which probability is highest, is it ना? Probability is maximum. ये भी पढ़ा हुआ है आपने CRV sir के साथ. So the mode of binomial distribution is the value of x for which p of x is maximum. अब mode find करने के लिए in the binomial we are having one of the specific technique. What is this? To identify the mode, हम क्या करेंगे अभी? We are not interested in the theory. We are just supposed to deal with the formula. So for that, I'm just giving you one of the flow chart. With that, you will be quite good to identify the mode. अब mode find करने के लिए आपको क्या करना है? If we are dealing with the binomial distribution, तब हमारे पास n और p दोनों की value होगी because both these are the parameters. Now we need to go for n plus 1 into p. We'll identify the value of n plus 1 into p. दो possibilities होगी, या तो n plus 1 into p की value integer आएगी, या तो वो non integer आएगी. If n plus 1 into p is integer value, if that particular value is integer, मानी कि उसकी value integer आएगी 2, 3, 4, 7, 15, like that, fixed integer. Then we will have two different modes. तो उस distribution के लिए दो mode होंगे. एक होगा n plus 1 into p और second होगा a number exactly less than that, n plus 1 into p minus 1. is it? अगर n plus 1 की वैल्यू मान लीजिए 5 आ रही है, n plus 1 into p की वैल्यू मान लीजिए 5 आ रही है, तो आपके पास दो मोड हो गए, एक 5, एक 5 minus 1 माने कि 4. So in that case, we will have two different modes, n plus 1 into p and n plus 1 into p minus 1. So, and if n plus 1 into p is non-integer, is not an integer, वो integer नहीं है, उसकी वैल्यू कुछ fraction आ रही है, like 2.73, like 3.12. If that particular value of n plus 1 into p is non-integer, then to identify mode, we need to deal with its greatest integer part, greatest integer function. Now, we are good with the greatest integer from our 12th, greatest integer of one of the function, one of the value x. Greatest integer का मतलब क्या था? गुजराती में जो याद कराऊँ तो x थी मोटो ना हुए वो मोटा मोटो integer. The greatest integer of 2.73 will be 2. The greatest integer of 3.12 will be 3. Or in other words, you need to identify, you need to deal with the integer part of that. वो जो भी नंबर आ रहा है उसका integer part जो है, that means for 3.12 उसका integer part है 3, for 2.73 its integer part is 2. In that case mode will be 2, in this case mode will be 3. तो क्या मैसेज है? अगर n plus 1 into p की वैल्यू integer आ रही है तो दो मोड होंगे. अगर n plus 1 into p की वैल्यू नॉन इंटीजर आ रही है तो उसका जो इंटीग्रल पार्ट है ना, the integral part of n plus 1 into p, that will act as a mode. As simple as that. So this is the way we can decide the mode for the binomial distribution. क्या ये बात समझ में आ रही है? Need a reply over the chat box अभी के अभी. क्या ये मोड वाली बात किसी हर कोई को समझ में आ रही है कि नहीं आ रही है? You need to reply over the chat box right now, please. Throw a message, shoot a message over the chat box. Whether you guys are able to understand these things or not. अगर नहीं समझ में आ रहा है तो दूसरी तरीके से भी समझा सकता हूँ. अगर समझ छोटी सी बात है, अगर समझ में आ रही है तो अच्छी बात है. एक ही को समझ में आ रही है, 1 2 3, ओके काफी सारे हैं, ठीक है. पार्थिव, मिलोनी, मिहिर, माहिर, यशपाल, निशिता, संजना, हर्षित, केयू, तिरका, गुड. शिल्पी कुमारी, कुशाल, केयूर, तोकिया, केयूर देसाई, जय कंसागरा, अनिल, दिशा, विद्या, Dipen, Daria. I need reply from all of you. Good. If you are good with this, then fine. Let's move for the. Okay, we also need to go for the reconciliation for the binomial, but I'm skipping right now because ये बात रखते हैं हम CRV सर के लिए. He will make you guys clear about this. But what I'm supposed to do right now, let's deal with one or two example related to binomial. तभी जो ये पूरा लेक्चर था, पूरा ये शेड्यूल जो पूरा ये जो 1.5 घंटे से हम लोग डिस्कस कर रहे हैं वो फ्रूटफुल होगा कि are you guys aware, are you guys comfortable to deal with the examples or not? So let me discuss one or two example related to binomial quickly, and then we will be ending this particular session. आज पूरा थियोरेटिकल सेशन रहा, कोई भी प्रैक्टिस सेशन नहीं होगा आज, क्योंकि I was supposed to give you the introduction of this particular unit. Okay, so quickly let's deal with one or two example. Example 1, the mean and standard deviation of binomial distribution is 5 and 2. कोई एक binomial distribution है, उसका mean जो है वो 5 है, and let me choose the different color, it will get it. Yes, mean जो है, the mean of distribution is 5. The standard deviation is 2. Now what we need to give, we need to identify, we need to determine the binomial distribution. We need to determine the whole distribution. Yes, that binomial distribution. If the mean of binomial distribution is 5, standard deviation is 2, then determine the distribution. Determine the distribution का मतलब क्या है? अगर कभी क्वेश्चन ऐसा है कि determine the distribution, that means you are supposed to give this particular formula. NCX, P raised to x, small p raised to x and q raised to n minus x. इस फॉर्मूला में जो n, p और q की वैल्यू है ना, वो 3 लिखनी है, x को छोड़ देना है ऐसे ही, and we need to even identify the value of x also. पर यहाँ पे x नहीं लिखेंगे. This is just a distribution, is it? So let's try to identify the distribution using this particular data. Let me quickly go through it. what the data we are having. We are having the value of value related to mean कि कोई एक binomial distribution का mean 5 है. अब हमको पता है mean की formula क्या है n into b. We are also having the value for the standard deviation. और हमको पता है अगर हमारे पास standard deviation है then we can go for the variance. Variance क्या होगा? The square of standard deviation, because standard deviation is the square root of variance. तो variance जो है उसकी वैल्यू भी 4. अगर standard deviation 2 है then variance will be 4. And we are knowing that variance is equals to n into p into q. So हमारे पास दो information आ गई अभी. n into p की वैल्यू 5 है, n into p n p into q की वैल्यू 4 है. We can take its ratio by any of the way. That means I am having n into p into q. इसकी वैल्यू जो है वो 4 है. मेरे पास n into p की वैल्यू जो है वो 5 है. So I can go for the ratio for both this. इन दोनों का ratio में ले लेता हूँ. In that way, n into p will got cancel out from the numerator, and q will be 4 by 5. Once we are having a value of q, अगर q 4 by 5 है, then we may go for the p. P will be 1 minus q. That means 1 minus 4 by 5. That will be 1 by 5. So मेरे पास n की वैल्यू अभी p और q की वैल्यू है. I'm supposed to replace. I'm supposed to identify the value of n. अभी n भी identify करना है तो एक और information है n into p equals to 5 as per the data. अब p I'm having the value of p is 1 by 5. So n into p की value मैं replace कर रहा हूँ. We are having p is 1 by 5. So n into 1 by 5 will be 5. That means n will be 25. So once we are having a value of n as well as q as well as p, we are good to determine a distribution. कैसे करेंगे? Let me resolve these things and let me show how you are supposed to write it down in the examination properly. वही बात है जो मैंने अभी explain की. देख लीजिए एक बार and try to get the things. क्या आपको ये बात समझ में आ रही है? Mean 5, standard deviation 2, तो variance 4 होगा. And taking that ratio, value of q, value of p, n into p 5 का यूज करके मुझे n भी मिल गया. So once we are having all this value q, p and n, we may write it down. We may go for the distribution. This is the formula for the distribution. और यहाँ पे क्या करना है? सिर्फ n, p और q की वैल्यू लिखनी है. n 25 as it is 25 cx, p is 1 by 5 raised to x, q is 4 by 5 and its power is n minus x. So n is having value 25 minus x. Now here observe n is 25. We are repeating this event for the 25 times. It means that, and x is number of successes. That means my random variable x can take value from 0 to 25. 0, 1, 2, 3 up to 25. हो सकता है कि मुझे एक भी बार सक्सेस ना मिले. हो सकता है maximum मुझे 25 बार सक्सेस मिले. So ये x can have the range from 0 to 25. 0, 1, 2, 3 up to 25. So this is the probability distribution for this particular situation. Hopefully it's quite basic. सभी को समझ में आ रहा है? सभी को ये बात समझ में आ रही है? हाँ या ना? बताओ जल्दी से. You guys are getting these things, is it na? Yes, good. Let's quickly go for the second one. Now, instead of identifying the distribution, here the question is extended to find probability that x is greater than equals to 2. Information जो भी है फिर से वही है. Mean की वैल्यू दी गई है 8. The mean and variance of binomial variate is 8 and 6, and we are supposed to find probability that x is greater than equals to 2. So let me show the solution without any discussion. ये जो पहला पार्ट है सॉल्यूशन का, देख लीजिए एक बार. Mean is 8, so n into p is 8. Variance is 6, so n into p into q is 6. Earlier we were having standard deviation, तो हमने स्क्वायर लिया था. अब यहाँ पे डायरेक्ट वेरिएंस दिया हुआ है. Variance 6 है, that means n into p into q is 6. And using the same terminology, moving with the same fashion which we had dealt in the last one, solving that we will have q मिलने के बाद p मिल जाएगा 1 minus q करके, और n into p को यूज करके n भी मिल जाएगा. तो p, q और n की वैल्यू अगर मेरे पास है, then I'm good to denote the notation, good to denote the distribution. That will be 32c3, 1 by 4 raised to x, 3 by 4 raised to 32 minus x, and as n is having value 32, तो x जो है वो 0 से 32 तक वेरी कर सकता है. So x can take value from 0 to 32 only, is it? So, but this is not the question. Question is about to get the value of just a minute. Okay, good. What we are looking for? We are looking for probability of x is greater than equals to 2. Now, what is this? Probability that my random variable x gonna take value greater than equals to 2. यहाँ पे x कितनी वैल्यू ले सकता है? 0 से 32 तक सारी, और मुझे 2 या 2 से बड़ी जो भी वैल्यू है ना x की, उन सभी के लिए प्रोबेबिलिटी चाहिए. दैट मींस व्हाट आई एम लुकिंग फॉर, आई एम लुकिंग फॉर p of x equals to 2 plus p of x equals to 3 plus p of x equals to 4 plus p of x equals to 5 plus p of x equals to 3 plus p of x equals to 32 even. ये सारी वैल्यूज, ये सारी प्रोबेबिलिटीज आइडेंटिफाई करके मुझे यहाँ पे ऐड करनी है, तब जाके मुझे मिलेगा p of x equals p of x greater than equals to 2. Now how to find that p of x equals to 2? ये कैसे करना है? Here this, what is this? This is p of x equals to x, is it ना? अब यहाँ पे मैं स्मॉल x यहाँ पे है, वहाँ पे 2 रिप्लेस कर दूं, then I will have p of x equals to 2. जहाँ पे x है वहाँ पे 3 रिप्लेस कर दूं, then I will able to identify p of x equals to 3. पर ये मैं कितनी बार करूं? 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 32. ये तो this is quite time consuming, is it ना? So do we have any alternate way? क्या इसको आइडेंटिफाई करने के लिए कुछ अल्टरनेट वे होगा मेरे पास? कोई एक? लेट मी आस्क दिशा बेटा, अनम्यूट योरसेल्फ.
इंटीग्रेशन.
ए पागल क्या बोल रही है? इंटीग्रेशन कैसे करेंगे? आर वी डीलिंग विद द कंटीन्यूअस रैंडम वेरिएबल? हम किससे साथ बात कर रहे हैं अभी? डिस्क्रीट डेटा के साथ बात कर रहे हैं कि नहीं? हाँ या ना?
यस.
ये प्रोबेबिलिटी डिस्ट्रीब्यूशन बाइनोमियल जो किसके लिए है? डिस्क्रीट रैंडम वेरिएबल के लिए. और डिस्क्रीट के लिए कभी इंटीग्रेशन यूज नहीं कर सकते. देखना, देख, इज इट? बी क्लियर विद दैट. इंटीग्रेशन कब हो सकता है? इफ वी आर डीलिंग विद द कंटीन्यूअस रैंडम वेरिएबल. यहाँ पे रैंडम वेरिएबल x जो है वो 0 वैल्यू ले सकता है, उसके बाद डायरेक्ट 1 ले सकता है, उसके बाद 2, उसके बाद 3, उसके बाद 32 up to 32, is it? X, it is not possible that x gonna take value 1.5. It is not possible that x gonna take value 2.5. ऐसे नहीं बोल सकते कि 32 ट्रायल्स में से 3.5 बार सक्सेस मिली, नहीं ना?
Then
So,
sir, we will find p of x is equals to 0 and p of x is equals to 1, and then we will subtract from 1 get both probabilities.
Perfect. Thank you very much. As we know that the total probability is 1, that means what? P of x equals to 0 plus P of x equals to 1 plus P of x equals to 2 up to plus P of x equals to 32. अगर मैं सारा ऐड करूँ ना तो उसकी वैल्यू 1 ही होगी, ये तो पक्का है. This is what the basic property of probability. Now, if I wish to identify this P of x greater than equals to 2, so instead of dealing with this particular part, if I'm going to subtract that particular addition of p of x equals to 0 plus p of x equals to 1, ये दोनों फाइंड करके मैं उसको 1 में से अगर सब्ट्रैक्ट कर दूं ना तो ये पूरा एडिशन मिल जाएगा, इज इट ना? अगर मैं इस फॉर्मूला के साथ डील कर रहा हूं तो मुझे टोटल 30 कैलकुलेशन करने होंगे. इफ आई एम डीलिंग विद दिस फॉर्मूला देन आई एम जस्ट सपोज्ड टू डील विद 2 कैलकुलेशन, और ये दोनों तो काफी आसान होंगे. x0 यहाँ पे एक बार रिप्लेस कर दो, फिर एक बार x equals to 1 रिप्लेस कर दो, आइडेंटिफाई कर लो. लेट मी शो हाउ यू आर सपोज्ड टू डू. यस, दिस इज द वे यू कैन डू. p of x is greater than equals to 2. Yes, Disha, you are absolutely correct. We are just supposed to replace, we are just supposed to subtract addition of x equals to 0 and x equals to 1 from 1. अगर उसको उसका एडिशन 1 में से सब्ट्रैक्ट करने के तो हमको p of x greater than equals to 2 ही मिलेगा. And to identify that p of x equals to 0 and p of x equals to 1, ये स्टेप लिखने की जरूरत नहीं है, छोड़ दीजिए इसको. अब चलिए एक बार मैं दिखा दूं कि हाउ टू फाइंड p of x equals to 0. ये कैसे करेंगे? p of x equals to 0 अगर आपको करना है तो क्या करना है? यहाँ पे जहाँ पे x है ना वहाँ पे 0 लेना है. तो 32c0, that means 32c0, I can write like this also. 1/4 raised to 0, x की वैल्यू हम 0 ले, 1/4 raised to 0 and 3/4 raised to 32 minus 0 माने कि 32. अब पता है 32c0, nc0 is always 1, anything raised to 0 is always 1, so ये दोनों की वैल्यू तो 1 है. and 3/4 raised to 32. अब ये आप आसानी से कर सकते हैं कैलसी से. 3/4 कीजिए, उसका पावर 32. It's totally convenient to deal with such kind of numbers. वो कैलसी तो अलाउड है, ये कर सकते हैं आप आसानी से. So solving that you will have p of x equals to 0. अगर आपको p of x equals to 1 के लिए जाना है तो जहां पे मैंने 0 लिखा वहां पे 1 करना है, p of x equals to 1 यहाँ पे 1 आ जाएगा, यहाँ पे 1 आ जाएगा, यहाँ पे 32 minus 1 माने कि 31 हो जाएगा. So all these things are quite convenient, is it? And by adding both that, we will have the value 0.9988. So this will be probably that x is greater than equals to 2. This was example number 2. अगर इसके लिए कोई डाउट है जल्दी से बोलिए, अभी बोलिए, तुरंत ही बोलिए. Parthy, was even correct?
Sir,
Yes, please.
sir, here we have a p of x greater than or equal to 2 and total outcomes we have 32. But if I
ना
if I
total
get
outcomes we are having 33. आपको 0 भी काउंट करना होगा इसका.
हाँ 33 sorry. But
Okay.
if I want to find p of x greater than or equal to 15, then how I will calculate from there?
Okay, greater than equals to 15 अगर आपको करना है तो क्या करना होगा? वो बीच वाला एक नंबर ले लिया इसने. देख, इसने ले लिया दिशा ने इस क्वेश्चन को काफी कॉम्प्लिकेटेड बना दिया. Let me wait. हाँ दिशा, let me erase the thing. I will just take 2 minutes. Don't worry. Let me erase all this ink. Yes. Now the question from the Disha is quite genuine. What she is asking, sir, अभी तो जब आपने बोला कि probability of x is greater than equals to 2 निकालना है, तो it was quite easy कि अब आपको 1 minus p of x less than 2 कर दीजिए, हो जाएगा. But what to do if I am supposed to find p of x is greater than equals to 15? Is it now? This is your question. Is it, Disha? I'm
Yes,
getting you
sir.
correctly? Good. In that
Yes.
case, what you can do, 1 minus p of x is less than 15 कर सकते हैं आप. या तो आप यूं ही कर ले कि 15 plus 16 plus 17 plus 18 up to 32. In both that cases, you are supposed to deal with quite big number of calculation, is it? इस केस में आपको 0 से लेके 14 तक ऐड करना पड़ेगा. मान के 15 कैलकुलेशन यहाँ पे भी होगी. और इन अदर केस यू आर सपोज टू डील विद 16 कैलकुलेशन. तो ये दोनों टाइम कंज्यूमिंग हो जाएगा. बट you can calculate this using Excel. even Excel का यूज करके भी हो सकता है, बहुत आसानी से हो सकता है, तुरंत हो सकता है, जस्ट a Microsoft Excel. पर फिर आपका क्वेश्चन ये आएगा कि सर एग्जाम में हम कहाँ पे Excel यूज कर सकेंगे, is it ना? So for the examination, none of the faculty will ask such kind of question. ऐसे क्वेश्चन एग्जाम में नहीं होते, क्योंकि उसको भी पता होता है कि भाई इसमें टाइम कंज्यूमिंग, दिस क्वेश्चन इज क्वाइट टाइम कंज्यूमिंग, इज इट? सो नन ऑफ द फैकल्टी विल आस्क सच काइंड ऑफ क्वेश्चन फॉर दिस सिचुएशन. वो अगर आपसे पूछेंगे तो इस तरीके के क्वेश्चन होंगे, x is greater than equals to 2, x is greater than equals to 1, like that. अगर फिर भी अब एग्जाम की बात छोड़ दे और फिर भी आपको करना है, then we are having a quite powerful tool with us, that is Microsoft Excel. Right now it's 11:27, so I will not able to discuss that particular, क्योंकि अगर मैं वो डिस्कस करने बैठ गया कि एक्सेल में ये कैसे सॉल्व करते हैं, then surely I am going to take your break, which is not ideal. वो नहीं करना चाहिए. So if CRV sir is not well for the next session, then surely I will be once again here to guide you guys. फिर मैं आपके साथ हूँगा और फिर तब मैं आपको बताऊंगा. अगर मैं नहीं हूँ so I will convey the message to the CRV sir. He will make you understand how to find such probabilities using Excel quickly. Excel में बस आपको एक फंक्शन यूज करना है, तुरंत ही हो जाएगा ये सब कुछ, is it? So एग्जाम की चिंता मत कीजिए, एग्जाम में कोई ऐसा नहीं पूछने वाला है. पर अगर आपके नॉलेज के लिए चाहिए, आपको सीखना है, तो Excel will be that. Surely that tool will help you, is it? So hopefully we guys are clear with this. किसी के दिमाग में और कोई डाउट है बताइए जल्दी से. Quickly, are you having any kind of doubt with this particular session, or we are good with this? Good. How was the session? Was it good, or I had made you guys quite bored? Session कैसा रहा? अच्छा, बढ़िया, मजा आया, नहीं आया? Honest reply देना, ऐसे नहीं कि चैट बॉक्स में डालना है तो फिर. Let me stop the recording. Wait.